So my name is Tomaz Janczuk, and I'll be talking about Node.js, serverless, and how it all applies to platform extensibility. So many web platforms out there, like GitHub, Twilio, Slack, and in fact Auth0, all offer a certain degree of customization. It can take the form of radio buttons, drop-down boxes, sliders, kind of a declarative form of extensibility. However, for many platforms, it only takes extensibility so far. It doesn't really allow you to do everything you want. So at some point, and it is very much the case in case of Auth0, you have to allow your users to write custom code to truly achieve the scenario that they are after. In Auth0, where I've been working for the past 2 years, we offer identity management as a service. And as part of the service, we allow our customers to write snippets of Node.js code to augment the behavior of authorization transactions. So these snippets of code execute during the actual login transaction and may potentially augment the outcome of the transaction. When you start looking at custom code as a way of customizing a web platform, a natural approach to this problem is to use webhooks. Webhooks create a decoupling between the custom logic that makes up your extension and the core platform. So when it comes to execute that custom logic, the core platform is making an HTTP request out to wherever that custom code is hosted. The custom code runs, potentially returns some results that augments the behavior of the core system. So this is how everybody out there is doing it today to allow extensibility through custom code. GitHub has GitHub webhooks. Slack is all over extensibility using webhooks as well. Many other platforms are doing webhooks. So all is great with webhooks as a model. However, webhooks come with a lot of baggage. As a developer who wants to use webhooks, you have to find a place to host that code. And with that come all the concerns that have to be addressed around really running a service, like scalability, maintenance, monitoring, expiring SSL certificates, and so on and so forth. So it creates a certain cost around extending any given platform using custom code. And what that frequently does to the kind of cost-benefit aspect of the situation is that certain features simply will not get done, because the value of implementing that custom integration is just less given the cost of engaging in finding the place to host the code and so on and so forth. So in Auth0, we've been in that situation 2 years ago, and kind of what runs in the DNA of the company is trying to make the end-user experience, and users of Auth0 are really the developers at this point, the end-user experience really shines. So we thought, what can we do better to streamline that experience for people? And this is where we had a little epiphany. Instead of letting people configure webhook URLs in our platform to enable them to run custom code, we actually enabled them to write that code directly in our platform. So what this did is that it took away all the concerns associated with finding the place to run this code, maintaining this code, scaling its servers, and so on and so forth. It took it away from the developer plate and shifted it onto, it made it Auth0's responsibility to run this code. So of course, what this means is that we now have to, since our platform is multi-tenant, we now have to have a secure way of running untrusted code. We don't know what that code is doing, really. So we had to come up with a way to isolate code of different tenants and to securely run it on our platform. As a result, Webtasks were born. Webtask platform is, you can think of Webtasks as a node sandbox for the cloud. It allows you to execute untrusted code in a multi-tenant situation in a safe manner. As a result of introducing Webtasks, we have changed the cost-benefit equation for our users, and it turned out to be a win-win situation. On one hand, the developers no longer had to put up with the effort of finding a place to host their code. So they suddenly started creating more and more of it. they were enabled to very cheaply add extensibility through custom code to the platform. We have benefited because it turns out that the more custom extensions people write, the more attached is being developed to the platform itself. So the more loyal customers remain to our platform. So going beyond the Auth0 application, we started looking at ways to provide that benefit of kind of serverless Node.js, serverless extensibility, to other platforms that follow a similar pattern of extending themselves via webhooks. And to that end, we created two experiences. One is command line based, and another one is web based. The intent here is to give developers a very, very easy way to turn a snippet of code, a function, a single function, into an endpoint that can later be used as a webhook in any of the other platforms like GitHub, Slack, or any other platform that exposes webhooks. So let's have a look at how that experience looks like. So we are starting from something extremely simple. This function doesn't take any inputs. It simply returns a hello string. So we are going to turn this function into an endpoint using the wt CLI command. So I have that file saved here in the hello.js file. WT is a command line tool that we have provided to manage web tasks, and we are just going to call it with the hello.js file. So what comes back is an endpoint. So we just took a function and turned it into an endpoint. And this is the essence of serverless. As a developer, you don't have to think about servers anymore. You only have to think about code. So all you really need is code. And we provide a very easy way, or any other serverless platform should provide a very easy way of turning that code into an endpoint. So just to make sure that it works, let's curl this. And hello undefined comes back for reasons that I didn't update this demo. So this is how that function should have looked like. Let's run it again. Recreate. And run. So hello comes back. So this is essentially what the function was doing. Now, oftentimes when you write backend code of any sort that provides any value, you reach out to downstream servers. It can be a Mongo database where you want to fetch some data. It can be you may want to send an SMS message, for example, using Twilio. In all of those cases, you need some kind of credentials to authenticate yourself to the downstream resource server. In case of Mongo, it is a Mongo connection string. In case of Twilio, these are Twilio keys. So how do you provision these secrets to your backend code, to that Webtasks code that you just saw? So we provide a first-class support for provisioning secrets using a context object that you can specify in the signature of your function. The Task Runtime, when it comes the moment to execute this snippet of code, will actually provide the secrets within the context object for you. So we can say hello context secrets my key. We'll call it my key. You can put whatever you want in here. It can be MongoDB connection string, but for the sake of presentation, I'm going to use my key. Now, when you create your hello function from the command line, you can specify the value of my key using the -s. So what happens here is that the WT CLI has taken the code of your function from the hello.js file, as well as the secret, and sent it all as a bundle to the Webtask management layer. That data had been stored. Your secrets are stored actually encrypted and only provided to your code at the time of execution. This is when they are decrypted. So never bake in any credentials into your code. There must always be some way of provisioning them from the context. So let's call this again. And you will see that the hello now responds with the ABC, which is the value of that key that we have extracted from the secrets bucket. So this, in essence, is the experience you can expect of taking a small snippet of code and turning it into an endpoint that you can later use as a webhook using the CLI. I also mentioned that we have a web-based experience, and you can very easily transition to that experience from the CLI itself. So we are going to edit that very web task we have just created in our web-based UI. So this pops up into what we call a Webtask editor. Webtask editor is a small web-based IDE that allows you to do many of the same things as the CLI itself. So you can edit the code, of course. You also have access to the same secrets that were specified on the command line before. So let's add a new secret here. We're going to call it foo, and the value will be bar. Save it. I'm going to change the code to now display the value of foo instead of bar. The IDE also allows you to execute that web task right from here, and you can see that when it runs, indeed, the response is hello bar, so the new value that we have provided here. One other interesting feature of that CLI is access to real-time logs, which provides some not quite time travel debugging unless you like scrolling. But nevertheless, it allows you to streamline the console log that we are all used to. New request. So if you run this, you'll notice that the new request showed up here in real-time logs. And you also have access to real-time logs from the console. So you can do WT logs in the console, and you'll get streaming real-time logging generated by your web tasks in the console as well. So these are the two experiences that Webtasks offer for a developer to take a snippet of code and turn it into an endpoint that you can later use as a webhook in any of the other applications. So let's, how many people here are using Slack? Everybody, yes. Slack is the new email. So we are all over Slack in Node.0. This is our primary communication channel for team members. We are a very distributed company, and Slack provides that bloodstream for us to kind of work together across time zones and geographical regions. But in addition to using Slack for person-to-person communication, we are all over Slack integrations. We are using it to streamline our DevOps operation, to generate real-time data reports, perform many business processes using Slack, like provisioning new accounts for new employees and so on. So we are very heavily invested in Slack automation. Just to give you an idea of the kinds of things that we are doing, for example, we have a report, signups. So this will generate a little report that shows signups to one of the services that we have in the recent 10 days. This is real-time data fetched from DynamoDB in AWS, turned into a Google chart that is simply sent back to Slack and displayed that way. We also use Slack for chat-ops. So we are very heavily invested in chat-ops. We can actually provision Auth0 infrastructure right from Slack by issuing a command along the lines of update, Skynet update, Auth0 Europe to a certain version number. This will kick off a Jenkins job. And after the Jenkins job is done, it will report back to Slack that, OK, you are now running on a new version of the infrastructure. So Slack is very provides a number of mechanisms for extensibility. The ones that we are using mostly are using slash commands. So slash commands are essentially webhooks, named webhooks. So you can refer to that and invoke that named webhook from Slack by issuing that slash and the name of the command. Slack will then invoke a webhook that you define here under that URL. And there is a certain protocol defined for what is expected on input and output from that webhook. Bottom line is that you have the ability to post some information back to Slack as a result of that function. So this gives you the ability to display some data back to the user. So this is all great. However, this extensibility model suffers from the very same problems that all the webhooks suffer, which is, as a developer, when you want to leverage this functionality, you really have to solve the problem of where to host my code, maintenance, health monitoring, and all this baggage that comes with running a service. So as a result, some of the things that really would provide value to the team never get done, because when you're facing half a day of work versus just 5 minutes, your kind of cost to benefit calculation may not pan out. So we started wondering, what can we do better in terms of Slack? How can we improve our own life on Slack such that we enable people to create those extensions in a much more streamlined way? And what was born at that point is a meta/webhook. So let's have a look at how it looks like. Oh, you know you're a power Slack user if you have to name your channel ZZZ just to keep things in order. So we created a slash webtask called WT. And this is a slash webtask that doesn't work. That can essentially is a moral equivalent of the WT CLI that you just saw a moment ago in the terminal. So it allows you to create web tasks right from within Slack and also run those web tasks run from within Slack. So you can think of it as a very dynamic way of creating slash commands. So let's take it for a spin. I'm going to create a hello slash web task, and it is created. And we can run it immediately from here. So it does a very simple thing. It responds with a hello and the name of whoever called that command, which in this case is me. So not very exciting. However, we have a piece of custom code running out there in response to a custom command. And it took me, what, 3 seconds as opposed to deploying something to Heroku or wherever. We can now go ahead and modify the code of that slash webtask using the webtask editor that we have just saw. So you get a bunch of instructions, developer instructions for what the payload is and so on that you can refer to. But this is really the code of the function that ran just a moment ago. So we are responding back to Slack with a hello and the name of the user that called that slash webtask. So just to make a proof of concept, let's change it to NodeConf. I'm going to save it, go back to Slack, and now when I invoke it, I get back the NodeConf. So, the cycle of making changes to your code and enabling new functionality on Slack via Node.js just became much, much shorter. We have thrown away all the concerns related to hosting your server, but we have also removed all the concerns related to wiring up the URLs themselves, right? So just by installing a single slash command, you now have access to that whole range of extensibility that Node.js allows. So the interesting thing happened once we enabled this functionality in Node.0 itself. It kind of caused an explosion of innovation within the team itself. Suddenly, many of the things that had been put aside because they were considered too expensive to do suddenly just happened because people felt empowered by the ability to just type WT, create my favorite slash command, and just write a snippet of Node.js. And many crazy things showed up on the scene. So for example, we've got a status command. So status is something that takes a little bit, and Slack has a 3-second timeout for that it allows the slash command to execute. So status reports on the status of all key components of the Auth0 infrastructure. So you can imagine, given that the entire life of Auth0 revolves around Slack, for our DevOps team, this provides a very handy mechanism to very quickly find out, okay, so what's happening in the system right now? We've got some alerts coming from Pingdom or some other monitoring systems. Let's check out the status of all the systems. So this will give you an overview. You can see that all systems are green right now, but if something is going down, you have some links that you can follow to Datadog and some details. You can start digging in. Another thing that our data scientist has created is called WT Lead. So WT Lead allows us to very quickly find out all the information we have about anyone of the sales team. And WT Lead is a mechanism to kind of bring in all this data right there to Slack. So you can imagine a salesperson on a call with someone, and they want to very quickly find out who that person is. What do we know about him? So they can do WT Lead, Tomaz Janczuk. So I'm going to put myself in here. And this command goes out to all the data sources that we have, data warehouse, many other systems that are tracking that data, pull everything we know about myself, and this is it, basically. So my role is engineering, which I'm kind of proud of. These are some attributes that inform the sales team of what categories of customers this person may potentially belong to. What's the fit score, how likely I am to become a paying customer, when did I log in last, my GitHub, Twitter handle, things like that. So very powerful things, are now enabled simply because the cost of creating those extensions was reduced with that serverless concept of Webtasks, and that make it available through Slack. So the good news is that we have not only made it available in the Auth0 team, but you can also go ahead and empower your own Slack team to do the exact same thing. So if you go to webtasks.io/Slack, you can simply click add this WT application to my Slack team, and literally a minute from now, you can be running your own Node.js code on your Slack team. So lastly, I want to take a minute to talk a little bit about the technology behind all of this, about Webtasks. So the key concept in the Webtask platform is what we call a Webtask container. Webtask container provides an isolation boundary between running code. If two Webtasks are executing in the same Webtask container, they may or may not be isolated. But if two Webtasks are executing in two different containers, they are guaranteed to be isolated in terms of in-memory state, networking, disk, and CPU. So this is the basic isolation mechanism that allows us to support multi-tenant platforms and execute custom code in the context of the multi-tenant platforms. Now, the key component of the system is what we call a Webtask Runtime. Webtask Runtime essentially is a reverse HTTP proxy. When a request comes in to execute some custom code in Webtasks, the Webtask Runtime will first see if that request, which is associated with a specific named Webtask container, is already associated with a Docker container, which is the fundamental mechanism that provides isolation at runtime. If such an association exists, Webtask Runtime will simply reverse proxy to that Docker container. Docker container will execute that custom code in an isolated fashion and send back any result to the caller. If such an association does not yet exist, so we have a case of a kind of a cold startup, we are trying to execute code in a Webtask container that we haven't seen before. Webtask Runtime at that point will fetch a new Docker container from the pre-warmed pool of containers and create that association to the Webtask container and follow through reverse proxying that request to that newly assigned Docker container. Now, the reason we have this kind of a distinctive feature of Webtasks is that we are keeping that pre-warmed pool of Docker containers. The reason we are doing this is that we care very deeply about cold startup latency. If you go back to that original scenario that we are trying to solve with Webtasks, which is extensibility of the authorization pipeline in the identity management product of Auth0, the actual scenario behind it is that we have a human sitting in front of a device waiting for his login dialog to close, because this is the moment in time where we are executing those custom snippets of code. So we don't want that to go on for seconds, because that would create a very bad user experience. So that's why we had a very early focus on optimizing cold startup latency. And this is why we ended up with a design that involves a pre-warmed set of containers. Now, the one implication of this design choice is that these containers have to be uniform. So what that means is that every Webtask, every snippet of code that you author on the Webtask platform executes in the same execution environment. And what that means in practice is that it has access to the very same set of Node.js modules that are already pre-provisioned in this environment. So how did we go about choosing that set of modules? We support about 900 modules out of the box. So you can do 99 percentile of your scenarios using what's already in the box. We simply looked at NPM, and there is over 400,000 modules on NPM today, I think. But after you crunch the statistical data, it turns out that 80% of downloads from NPM is made up by 600 modules only. So we just took that 600, shoved it into the platform, and therefore we satisfy a vast majority of scenarios. It's a kind of a Pareto rule. So in addition to the Webtask Runtime, we also have a little management component, which exposes management HTTP APIs. This is the layer that WT CLI and the Webtask editor are using to communicate with, to create webtasks, list webtasks, and so on. So serverless Node.js, this is the essence of the talk. Thank you, and don't forget to install that extension in your Slack team.